So Bryce, what did you share? What was one thing that stood out to you?
I said that from the Bryson reading, I thought that it was kind of crazy that the universe at one point was like that small and fit into such a small space, and now it's huge.
Yeah, the idea of a singularity where all matter existed. It's kind of funny though when you start thinking about the size of it, right? Like Bryson kind of hints that it was small, but really what he's saying is it was really compact because we can't really compare its size to anything because did anything exist back then? Didn't really. So it's
Yeah.
kind of unknown dimensions. But you're right that it was so compact that it was probably extremely small compared to all matter in existence. But yeah, kind of interesting idea. Camille, what was something that stood out to you?
Sophia and I were talking. We thought that like the fact that there was like nothing around it before, like you can't even think like what was around it because there's just nothing. And then also like how it just like created a universe that's like so like perfect. Like it didn't like mess up or like have any slip up or
It's an interesting concept of like, yeah, things were created. I mean, it is interesting seeing spherical planets and things like that. There definitely were explosions and things that imploded and stuff, but yeah, I like that idea of like a perfect sort of formed universe. And yeah, really cool that it's expanding out and it's creating space, right? It's not like space was there and then the stars went out into it. What we see, the stars spreading out, they're creating that space. So that's a good point. Anyone else have any points they wanted to share or thought were particularly interesting? Sophia Bozo?
I thought it was interesting, like I read in one of the parts where it was like it creates its own space to like fill into, which was so crazy because like there wasn't space, it wasn't anything. It was just like I don't know, like an abyss, but it wasn't even that. And then it like the universe like literally created its own space and it's like been expanding into that space, except they found the edge of the universe apparently, but I don't know.
Yeah, well, but that idea of that edge is constantly going outwards, though, right? That space is still expanding, and that's something we'll touch on. But yes, that to me too. That was a new revelation. I had no idea. I always thought there was emptiness, and then it was filled by all these stars spreading out. But it turns out no, there was just nothing. It's kind of weird. All right, going to do this one more time. New prompt this time. So I've rearranged the breakout room. So hopefully you're with somebody new. This time, I'd like you to again just introduce yourselves and then share, if you're willing, what your beliefs are in terms of how the universe and other things in life was created. Same thing, we'll go for 3 minutes. Go for it. I won't go around and have people share different things because I know this is more of an opinion based question. But what I want to just make clear and say to you is that I'm not trying to like squash anyone's religious beliefs or anything like that. I think there's lots of value in those. We're just going by what's in the textbook. I think there are a lot of ways of melding science and religion together. I don't think it's not healthy to think of a right or a wrong way of thinking about this. I think you all just form your own opinions and as you learn about it. So I'm not trying to step on anyone's beliefs or anything like that as we go through this. So, all right, next thing before we really get into content stuff was to share a couple of our Google collages. So I don't think we had anyone go last time. So would anyone like to volunteer to be the first person to just show off your collage? I'll share my screen and pull it up and you just talk us through the images. Would anyone like to go first? I will pick you randomly if not, just warning you. Daniela, you feeling ready?
Sure.
Okay, give me 1 second to find yours. Bingo. Okay, I'm gonna share my screen. Might take a second to load. Everything's moving a little bit more slowly now that all these tabs are open. All right, talk us through it.
Okay, so my name is Daniela. I live in Marina, California, which is near the college of CSUMB, which is why there's that little otter there, if you know where that is. During the summer, I watched a lot of Netflix. I went to the beach a lot until they closed down again. And I redid my room, but I really just like painted the walls and redid the floor because I'm allergic to carpet. And the topic that I'm mostly interested in is marine biology, but more specifically like sea otters, because I don't know, I just really like them. They're just so fascinating, especially how they like recovered from that big I don't know, like
Yeah,
they like
mass
almost
extinction.
went extinct. Yeah,
Hmm.
yeah,
Yeah, they got hunted into nothing. They thought they were gone, and then they found one small population in Big Sur, and yeah, now they're all the way back up the coast. So that's
yeah.
great. Yeah, they're fascinating as a keystone species. So,
Hmm.
what color did you paint your room?
The walls are just gray. They look kind of blue, but they're just gray.
Cool. Yeah, I also, it's funny, I used to love going and I used to pretend I was a student and would go work in some of the common spaces that they have at CUCUMB. I just love their workspaces. It was a great place to go and grade. I'm so bummed that they're all closed down now. But those are the times we live in. All right, thank you for sharing. Who would like to go next? Again, I'll pick you randomly if, all right, let's have Ronan. You ready, Ronan? Give me 1 second to pull yours up. All right, talk us through it, Ronan.
All right, so my name's Ronan. This summer I watched a lot of soccer, and at home I have two dogs named Kaya and Cody. One's a golden doodle and one's a terrier mix. This summer I went to Lake Tahoe for a little bit, and I also went to the pool a lot with my friends. And I'm currently curious in physics and biology.
Nice. Boy, those are two energetic dog breeds. They must keep you busy.
Yeah, definitely.
Whereabouts in Tahoe did you go?
Like northern Tahoe.
Nice. Do you go there often, or is this like your first time in that area?
Not in the summer. I usually go to the ski a lot.
Yeah. Yeah, it's different in the summer, but just as
Yeah.
crowded, I feel like. Good place to own rental property. You can get year-round visitors. So that's awesome.
Yeah.
Okay. Thanks, Ronan. Anyone like to go next? Who will my next victim be then? Lena, you feeling ready? Let me pull up yours real quick. Let's see. You shared yours with me, right?
I think so.
Do you know what you titled it? There are two with no name in the title, which means someone wasn't following directions. Oh, hold on, let me just preview real quick. Yeah, let me share my screen here. Lena, can you see, is this one yours, possibly?
Yeah.
Yeah? Okay. Talk us through it.
So let's start with my preferred topic to learn in science would be biology, evolution. I have a golden retriever. I moved to Korea from England over the summer, and the cake represents my love for baking, and it was my birthday on September 2nd. I like to sing, so there you have the karaoke. That's not my favorite song, but it was just there, so I chose that.
Nice.
And then I read The Book Thief over the summer.
Awesome. How long had you lived in England before moving back?
4 to 5 years.
Oh, wow. All right. What's your favorite pastry to bake?
Fairy cakes, or just, I like bread too. I like making bread.
Nice.
Just, yeah.
And what would be your top karaoke song? Like if that played, what would you?
She Used to Be Mine by, I don't really know how to pronounce her name, but it's from a musical.
Nice.
Yeah.
Cool.
Actress.
All right. What'd you think of The Book Thief? Kind of a heavy one. Good book, though. I always liked it. It was just kind of sad. All right. Thank you very much for sharing. All right. Let's squeeze in one more. Anyone else like to go? Eric, are you feeling ready? All right, let me pull yours up real quick.
Yeah, I feel this coming. Like when I look into like Mr. High's eye.
Yeah, you just knew
Yeah, it's coming.
you knew
It's
I was
coming.
looking at you.
Yeah, I feel like you're looking at me.
All right, here we go. Nice. All right, talk us through it.
Yeah, one of the half images. Like, yeah, I'm just waiting for the alt image to load. Okay, so the figure in the middle doesn't look like me, but like the yellow face, like the yellowish little giddy face does. Yeah. So just basically describing all those things. So first of all, you see like the basic descriptions below it. There's something there. No. Yeah, so my name is Eric. Anything you call me, like any nicknames, encouraged actually, like accepted. Just don't make it too difficult, like because I have this, amoeba styled brain. So amoeba doesn't have a brain, but like if in a case like you call me something that's too complicated, I won't be able to understand. So yeah. You see like this guy playing violin. I do play violin. I've been playing since the beginning of memory, which starts at like 3 years old. I basically forget how I peed on my blankets when I was like 2 because I didn't remember. Also, like choosing from the background, I love mountains. So you see like there's mountains in the background, but I only like them when they're in the background. I don't like, in the mountains because mosquitoes, hornets, and all those centipedes, they bother me for some while.
So like looking at them but not climbing them.
Yeah, that's why like they're only in the background and not in the front. Yeah, I had this night where like 20 hornets just invaded my room, like in one of the mountains, and I had to spend like 5 hours killing all of them. It was a very unforgettable experience. So judging from like this figure here, like this, like doing this kind of action, like I'm interested more or less like in human body, but like more in human mind than like the body. Like I'm more into the physical part, like in the mental part of this body, like psychology, sociology, how people react, like this micro expression thing, like this kind of philosophy, this kind of thing that relates to science, like forensics, like how you analyze like human body as like this kind of this figure, how you analyze, how you dissect like the minds, like how humans think, how we react to like special like to changes, like to reactions about like outer environment. I think that's very like attracted to me.
Nice.
And also the socks on my shoulder represents my sister because she loves tossing socks onto my shoulder and literally laugh her ass out when I just go around carrying a socks without noticing. Yeah.
Is this a younger sister or older sister?
Judging from the action, younger sister.
Nice. All right. Great. Well, thank you for sharing. That's pretty good. Okay. In the interest of time, we will stop there, but we'll just continue doing that in our next few lessons till we've gotten through everybody. So thank you for the 4 of you for sharing about that. What I want to move on to now is a little bit of content. So bear with me. I'm going to try to rig up my iPad here and walk you through some slides that'll preview a reading. And I'm going to need your help getting through some of this as well. So in terms of participation, just going to throw some questions out. Feel free to just hop in. I'm not going to be able to see you, so just unmute yourselves and jump on in if you think you've got answers, and don't be afraid to take guesses. All right, here we go. Let's get the iPad up and running. Okay, everyone's seeing a slide in front of them? I'm gonna need verbal communication. Yes?
Yes.
Awesome.
Yes.
Okay, so welcome to the cosmos. We are starting off with cosmology, study of space, and specifically the Big Bang Theory, as you read about in Bryson. So cosmology is just the study of all of that, getting out into space and stars and everything around us. And the only tool we really have are telescopes. All we can do is look outward from our planet or launch telescopes into space. That's what the Hubble telescope is. and just magnify the stars that are around. And so really we're dependent upon the light as it reaches our planet. So does anyone know much about light speed? Does light move fast compared to sound? Faster or slower than sound?
Way faster.
Good, way, way faster. Light is unimaginably fast. And yet the universe is so huge, exceedingly large, that a lot of the light that reaches us from a star started its journey almost hundreds of years ago. And so even though we're seeing a star as light is hitting Earth, we're actually looking back in time. That's where this title comes from, right? Is that you're seeing that star in the past. And so it's sort of depressing to think, though, because if there are intelligent civilizations out there, we might not be able to see them because we're not seeing the light from their current existence. We're seeing the light from ancient times. And the same thing, if they're looking out at us, when they look at Earth, they're not seeing humans walking around. They might be looking at dinosaurs, or not even that. They might even just be looking at a barren planet because life hadn't gotten started yet. So kind of an interesting idea. But the farther away an object is, the older it probably is, because of that rule of light traveling. Even though light goes so fast, the universe is so vast that we have this sort of time delay difference. Somebody who made a big breakthrough looking through the telescopes was Edwin Hubble. He was working in the 1920s. He observed two things that you need to remember about that. And he's who they named the Hubble telescope afterwards, which we've launched into space. But he first made the observation that there are actually other galaxies. Again, we humans tend to be very human-centric. We think we're the center of the universe and there's nothing else. But he identified there are lots of other galaxies around, and that they seem to be spreading apart from each other. And so this has two big implications. The first one is that the universe seems to have begun from some kind of explosion, right? It's rapidly expanding outwards. That's the idea of the Big Bang. And that it's still expanding and creating space as it goes. A lot of you mentioned this when Bryson kind of described that there was nothing, there was just emptiness. And then space has been expanding out into it. I like this as analogy your book uses here of someone blowing up a balloon that has ants on it. All those little black dots there are ants. This is what space is doing. If you think about those ants as galaxies, they're all moving apart from each other. But here's what's really cool. If I were to look at one particular ant, let's say that one right there, from that ant's perspective, what it can see, everything is moving out away from it. So that ant thinks that it's the center of expansion. But then that's the same story for this ant as well. And so it's sort of interesting that since everything is moving out away from everything else, right, there's no real center. We can't really identify, well, that's the middle of our universe and everything's expanding from there. Because once the Big Bang happened, everything just started expanding out from where it was. Kind of an interesting idea. All right, Hubble came up with a little mathematical equation, which again, I'm gonna try to keep it as simple as I can. It's just this, V equals H times D. It's a relationship, a proportional relationship between the distance of an object from Earth and the speed at which it's going. And so really what this equation is saying is that the farther away an object is, the faster it's going, right? That's kind of the key relationship to remember there. Velocity is measured in kilometers per second. Distance is in megaparsecs, which is an insane distance. It's 3.26 million light years. That's an unimaginable distance. And Hubble's constant H is just a number. It's 73.8 kilometers per second per megaparsec. I'm not entirely sure how they determine that, but that number has been set for a while. And they do some fancy math with this to try to figure out the average age, like when did the Big Bang occur? And the consensus right now seems to be that the universe is about 13.7 billion years old, which again is a huge amount of time and it's kind of hard to wrap your mind around. But that'll be helpful for the whole timeline thing we're gonna do. This will help you with the reading quiz that you're gonna have to do, but let's do a little algebra, right? If we know Hubble's law is this, V equals H times D, and we also know that velocity is just distance over time, well then why don't we replace that V with this? What if we were to plug in Hubble's law right in there? So here's our new equation. We've replaced Hubble's law with the velocity. Notice we've got distance now on both sides. And so if I were to divide this by distance and divide that by distance, does anyone know what happens if you divide distance on the bottom and distance on top?
They cancel each other out.
They all cancel out and we're left with this, which is again is a bit of an oversimplification, but it shows you there's sort of a relationship between Hubble's constant and time. And this is what they use to try to figure out, well, how old is the universe? Again, there's some more complicated math going on there that I don't fully understand, but if that gets you interested, you can look it up. As Bryson mentioned, there's a little bit more evidence supporting this Big Bang theory. He talked about Penzias and Wilson. They built this gigantic satellite you see behind them. They were trying to listen to radio waves. Bryson kind of jokes about how birds used to poop in this all the time and they had to constantly clean it. But they ran into a problem because they were just trying to pick up radio waves, but they kept picking up this one signal, a microwave signal that no matter where they pointed this thing, they got the exact same thing all the time. And it took a little bit of working together with this group in Princeton, but they figured out that what they were hearing is the afterglow of the Big Bang, right? This huge explosion where everything was really, really hot. The universe is now cooling down, and those microwaves are just a form of energy that's being released by this universe as it cools down. And so they point to that as just evidence of this large explosion, this Big Bang that generated the universe. The final piece of evidence that the book discusses is this idea of how much hydrogen and helium there is in the universe. And again, it's sort of mind-boggling how they know this, but looking at all matter, and I think they study isotopes and samples, but out of all matter in existence, they're pretty confident that about 75% of it is hydrogen. It's the most common element and the simplest element. And the other 25% is helium, which is a little bit more complicated. You can see it down here, right? Hydrogen is just one proton, one electron. Helium is actually 2 protons, 2 neutrons, and 2 electrons. And helium is made from hydrogen. It's a fusion reaction that occurs in stars. So stars, as they're burning, including our sun, all the energy that comes from our sun is a fusion reaction where hydrogen atoms crash into each other and form helium. But here's the issue. Stars and their activity only really accounts for about 10% of helium in existence. So where did the other 15% come from? Where did all this helium, what generated all this helium? And they think that it was the extreme temperatures of this very large explosion that started off the universe, the Big Bang. So in summary, the chapter you're going to read, which is chapter 29.7 in Hewitt, is just talking about the Big Bang theory and the evidence behind it, which again is Hubble observing that galaxies seem to be expanding outwards still from an explosion point. The cosmic background radiation is sort of this afterglow, this very large explosion, and the hot temperatures help explain the observed proportions of hydrogen and helium in the universe. Any questions about that right now? Again, you're going to read more about that tonight, but any questions or comments on that?
I missed the first slide because I was grabbing my journal.
Mm-hmm.
What's that about?
First slide was just looking at cosmology being the study of space and existence, and how we really only have telescopes to allow us to observe that. And the problem is that light, even though light moves really fast, the universe is so big that when we look at a star, we're not looking at that star like it currently is right now at this time. You're seeing it almost maybe 100,000 years ago, right? Because the light had to travel so far to get here. So that's the idea of that we're really only seeing the past of the stars that are outside of us. That's what I was touching on. Mm-hmm.
Okay, thank you.
I have a video recording of me going through those same slides. So if you missed anything, you can go back and watch that as well. That's on the tasks list. So any other questions or comments? Okay, well, let's get you going on an activity then. I believe the next thing I want to do is, if you look at the tasks list, we are now on step 4, history of the universe, make a timeline. So I'm going to ask you to create a sort of paper timeline, like a long strip that we're going to use to represent 14 billion years of history. And I'm going to give you a couple key events that I'd like you to map on this timeline. I have instructions for it. So if you look on our tasks to complete for U1L2, look at step 4, and that says follow this history of the universe timeline instruction. Click on that, and it should take you to a Google Doc. I'll share my screen here really quickly. Here's what that Google Doc will look like. So again, just to go back to, here's our tasks to complete list, right? You're looking at step number 4, history of the universe. Click on that link right there. And that doc has instructions in it. So I've got an example of what you're going to make. I have a short instructional video that I made, and I also have written instructions on how to fill that out. But what we're going to try to use is toilet paper, because you don't really have to measure toilet paper. You hopefully all have toilet paper at home that's available. And so you're going to count out 14 squares of toilet paper. Each of those is going to represent 14 billion years, and the instructions will walk you through the rest. So I'm going to give you about 15 minutes to work on this, and 20 minutes to work on this. And I'll be here listening if you need help on anything. You are going to be sharing this by posting a Flipgrid video. So once you've got your guesses, I'm going to have you guess where the events happen and then map the actual events. You can decorate it too if you want. And then just take a quick video going all the way across. A link to the Flipgrid is also on that tasks list right there. If you just click right there, and you can watch an example video that I have there as well. So go for it. I'll time for 20 minutes, and I'm listening. If you have questions or if you're not sure what to do or you're missing a certain supply that might be helpful, just let me know. Go for it. How'd that work? Most people able to use toilet paper? It's a little tricky to write on, isn't it? Kind of depends on what ply you've got, though. You know, if you're a 3-ply person, then that's pretty good. But if you only got the 1 ply, then not so good. I've got mine hanging on the wall behind me. You're welcome to hang up yours as decoration too if you want eventually. But you can see mine right above the little glass whiteboard there I've got. Anyone willing to hold theirs up? Whatever progress you might have made. We're all too ashamed. So it's okay if you didn't finish or you weren't able to post to the Flipgrid. This will just roll over into the homework. The point of this was to show you that once you start entering the actual numbers in, have human beings existed for a significant amount of time? As important as we think we are, especially when you look at the amount of time the dinosaurs had on our planet, even relative to our own existence, it's almost nothing. We are pretty insignificant. So it's kind of weird to start thinking about. And also just, it's so impossible to grasp even how old life is compared to then us, right? We're just a culmination of this ongoing evolutionary process. So anyway, I thought that was kind of interesting. Who knows how long we will last on this planet? Hopefully, if as long as the dinosaurs, if not longer, but we'll see. But that was the point of that, was to kind of give you an idea of just how old the universe is and just the crazy amounts of time that have gone by. So I just want to highlight the homework, looking at our tasks to complete list, which we've been going through in class. A couple things I'd like you to do. The main assignment, make sure you finish your timeline and post it to the Flipgrid if you didn't get that done in class. Hopefully you got most of that done in class. There is going to be a reading, Hewitt chapter 29.7 from your Hewitt textbook. Again, if you don't have the textbook yet, don't freak out. I've got a digital version right there. If you click on that, it'll take you to a PDF of the relevant pages that you can read on your computer. I would like you to take notes in a notebook. All right, I know this sounds old-fashioned, but you should all have a graph paper notebook like this. And I would like you to actually write notes in this. I think it's important to get away from our screens when we can and still try to write things out. There's value in that. I know some people like typing, some people like to keep digital notebooks, so I'm gonna ask you to write in this notebook. And there's a certain format I'd like you to follow, just to stay relatively organized, where you're noting the unit, the chapter that you're reading, the date, and then just write down a couple of vocabulary terms from the reading and a couple notes from the reading. That's all I'm asking at a minimum. Now, if you have your own system for note-taking and it's organized, go for it. You can stick to that system. But if you don't, then please try to follow this format. This will be graded. I'm going to ask you to submit a photo of just one page of your notes. It'll be a 5-point grade. So please make sure you're doing that. Then you can refer to those notes or to the book itself to complete what's called the reading check. That's the next item right there. It's just a short quiz. You can take it up to 10 times to get that perfect score. So you can retake it up to 10 times to get the full points. But that's a homework assignment right there. And then the last one is just an academic honesty agreement. All you have to do is peruse through it. It's the same stuff that was on the course description, and sign it by typing your name. That's the only thing you need to do. Questions on homework assignments? All right, kiddos, then I will see you on Wednesday. Thank you very much. Have a good rest of your day.
Thank you, Mr. Nate.
Yeah.
Bye-bye.